Okay, I want to find the location of the centroid for this solid. Okay, the equation that we'll use to find this y location, y bar, is going to be y tilde dv divided by the integral of dv. So I need an infinitesimal volume. So what I'll do is use a thin disk like I have right here. And that disk is going to have a thickness of dy, okay? And it'll have a radius of what I'll call z, okay? Because it goes from the axis up to that curve there, which I'm going to call z. Okay, and again, this is at some arbitrary distance, right? Therefore, the volume on this guy, dV, is going to be pi r squared times the thickness. That's the volume of a cylinder, where my radius is z and my thickness is dy. So that is my infinitesimal volume. Now, the other thing I need is the location of the centroid, which is just going to be some arbitrary position y as I move and integrate this. That y will change along with it, and that's the location of the centroid. So using that, I just come up here and I get y times pi z squared dy. And then on the denominator, I just get the pi z squared dy. I'm going to integrate this ultimately with respect to y, so my limits of integration are along the y-axis from 0 to 4. So that'll be on both of these, okay? And of course, I need to get rid of that z because I need everything in terms of y. Now, of course, I know z squared, that's given to me as y cubed over 16. So I can just substitute that in, and I get the integral from 0 to 4, y pi. Now, instead of z squared, I'm going to use y cubed over 16 dy. And I'll get similar on the bottom one, 0 to 4. No, there's no y on this in front of this one. It's just the pi times y cubed over 16, which is what z squared equals. That'll be dy. Okay. So again, you can go through, do the integrals on your own. You can do it by hand. These are just polynomials. They're pretty simple to do. I'll let you do that on your own. You'll get a numerator of 204.8 when you do that integration, and you'll get a denominator of 64. Therefore, the location of the centroid is 3.2 meters. Okay, which again means that the centroid is, I don't know, somewhere right about there. Okay, that's your centroid. Okay, which again makes sense that it's closer to the flat side because there's more volume over there than over on the pointy side on the left side. Okay, so again, just use y tilde times infinitesimal volume, figure out the infinitesimal volume using a thin disk, writing the equations, and then doing the calculation.